Welcome to my MYP5 personal project, where I will attempt to dive into how smart farming can revolutionize West African agriculture through the research question. To what extent can innovations develop and allow for sustainable, smart and cheap agriculture in West Africa? Let's first start with the most basic concept, agriculture, the backbone of human civilization, providing food, livelihood and resources for billions of people, and serving as the pillar for our modern world. In terms of our world, let's focus on West Africa, the region with the youngest population on Earth, where nearly a third of its GDP depends on agriculture. In fact, 27% of West African countries' GDP comes directly from agriculture, compared to just 10 or 5% for the median and average countries, showcasing just how crucial farming is here. But why is this the case? The answer lies in West Africa's deep agricultural roots. Long before colonial times, crops like cassava, rice, millets and yams sustained life and trade in regions like the Upper Volta, the Gold Coast, as well as Dahomey. Then, colonial powers like the French and British Empire expanded the agricultural landscape, introducing the mass farming of crops like cotton and palm oil. This combination of cultural and colonial history has made agriculture a defining part of West African life and the economy today. Now, we'll look at the current state of West African farming, explained by a leading expert.
Je suis le responsable agro-business au sein de la Banque ouest-africaine de développement. Pour savoir, aujourd'hui, nous avons en fait en Afrique une agriculture qui est purement familiale. C'est des familles qui sont à l'intérieur des régions de nos pays et qui exploitent des lopins de terre de très petite superficie. Et c'est l'agrégation de tout ça qui permet d'avoir une production nationale qui a une certaine échelle. Et généralement, à l'intérieur de nos pays n'ont pas accès à l'eau pour irriguer la plantation. C'est un défi aussi qu'il faut adresser à travers notamment des barrages, des forages pour apporter de l'eau dans les différentes zones de production. Donc voilà un peu la problématique de l'agriculture en Afrique. Et c'est ces différents défis-là que nous devons adresser pour que notre agriculture soit plus résiliente et qu'on puisse faire face au pic démographique qui est attendu pour 2050.
As we could see in the video, despite using a relatively low amount of water and energy, West African farming is still highly inefficient in the use of both. And with Africa's population predicted to grow to 2.5 billion, and the median age being 19.2 years old, this inefficiency will pose serious challenges for future demands. However, there is a solution. We can develop a new efficient and sustainable farming model using technological and scientific innovations that can meet Africa's future demands. Now let's dive into the technological farming model that can secure a sustainable future for the West African region. To start, one key innovation of this model is the use of terrace farming, notably used by the Inca civilization. Traditional West African farms are often situated on flat terrain, leading to significant use of manual water distribution. Terrace farming solves this by creating sloped step series of plots along the contours of the land, emphasizing the natural flow of water going down the farm, therefore allowing for less need to pump the water across the farm itself. Compared to conventional farms, it can significantly boost crop yields and reduce energy demands. Another important innovation is the use of a rainwater collection system. West Africa is characterized by heavy seasonal rainfall, but most of this precipitation is lost to runoff. Farmers can install rainwater harvesting tanks and channels next to their barns, capturing the water in large numbers during the rains and using the water during dry months. In our case, we'll have a system on top of our farm's maintenance barn, just like we could see in the video before. Harvesting rainwater can satisfy up to 1/2 of the farm's annual water requirements, reducing irrigation costs by a similar margin. Adding to the rainwater system, a smart water pump is needed to satisfy the other half of our water needs. Modern hand or diesel-powered pumps are very inefficient and labor-intensive. By transitioning to solar-powered electric submersible pumps, we can access our groundwater with a fraction of the efforts and energy costs. Combining a rainwater collection system with this smart pump will reduce a farm's total water usage by 1/3 compared to models and methods used today. Another key innovation is the integration of solar panels. By installing these photovoltaic panels on our barn and on unused potential lower land, we can generate our own renewable power to provide electricity to all our machines. This not only reduces our reliance on polluting diesel generators or the grid itself, but also creates opportunities for farmers to sell excess electricity back to the grid. Solar power can meet almost all of our farm's energy needs, lowering operating costs and carbon footprint and maximizing sustainable development. Complementing the water and energy systems, a smart irrigation system is crucial. Traditional manual irrigation methods waste a significant amount of water through lack of scalability and efficiency in respective usages. These smart systems will be based on pure data, automatically adjusting the amount of water it sends through its pipes, and can end up reducing water usage by 20 to 30% while increasing yields through improved efficiency. The system can also be integrated with software applications, as we will later see, allowing farmers to remotely monitor and control irrigation from anywhere. Collecting all of this data will be another key focus area. The soil monitoring system will use in-ground pH and soil moisture sensors. This data will then be fed to the irrigation system and the overarching SCADA system to provide farmers with in-depth data related to their crops. By tailoring inputs to the specific needs of their land, farmers can boost yield significantly and know almost everything about what is going on with their crops at all times. Another innovative solution is the use of clay cooling pots for post-harvest storage. In many parts of West Africa, farmers lack access to reliable and cheap refrigeration, leading to significant food waste or spending. Clay pots, when filled with water, use evaporative cooling to keep crops fresh for up to 3 times longer than traditional storage methods. This low-tech approach reduces spoilage by 30 to 40% while requiring no electricity or fuel. The pots are also inexpensive, easily produced locally, and environmentally friendly. Waste management, one of the final aspects of our solution, is another critical part of this farming model. The natural waste composting system will transform organic farm waste, such as crop residues, into nutrient-rich fertilizer by using worms and organic waste. This approach improves soil health, reduces the need for synthetic and often environmentally damaging fertilizers like the NPK fertilizer, and will ensure a healthy environment around our farm. All of these innovations together is an integrated control system based on SCADA technology. This centralized control system will allow farmers to monitor and manage key aspects of their operations from a single mobile app or control panel, increasing efficiency and automation. All in all, our model would include all of these technologies into one, with the hopes of solving our incoming population and resource crisis. So, how does our model stack up against a traditional farm today? Let's look at a hypothetical 1-hectare farm. We first import comparison values into our custom calculator. We input values for the standard model and the one we have just explored. We can then visually compute this, and from what we can observe, our model beats the standard model in almost all categories in terms of yields, cost over time, and others. If we look deeper, we can observe our model has a very high initial cost, one that may prevent it from being implemented today. Therefore, the data showcases just how effective technological innovations are in a farm, but with the caveat that the implementation requires an economic leap of faith from governments, one that they may not choose to do. If this leap is taken, however, this kind of transformative change could impose high costs, but also secure a prosperous, sustainable future for the West African people, even with its growing population. In this documentary, we've covered the diverse agricultural tradition of West Africa, the challenges it currently faces, and the life changer, agricultural innovation. Agriculture, which accounts for almost 1/3 of the region's GDP, is intricately bound to West Africa's culture, economy, and future, as we have explored cultural roots through colonization and old history, dependence through our chart visualization, and future in terms of the growing population. However, in light of the population expected to nearly double by 2050 and rising resource demands from this population, the demand for sustainable, smart, and efficient farming solutions is now more urgent than ever before. Guided by the research question, to what extent can innovations develop and allow for sustainable, smart, and cheaper agriculture in West Africa, we have been able to explore a model that incorporates advanced technologies like terrace farming, rainwater collection systems, amongst others. These In simpler terms, recalled by Frederick Douglass,
"There is no progress without struggle" best describes this project. On one hand, it has potential in leading West Africa in sustainable agriculture for generations to come, providing food security for our children and grandchildren. But on the other, it costs a lot of money to initialize and to set up, requiring careful planning from the government. Hence, the exact extent to which innovations could develop and allow for a sustainable, smart and cheap agriculture in West Africa is one that is rooted in government economic risk-taking and planning. Thank you for joining me on this journey into the future of farming in West Africa.